Okay, section 5.2, objective 2, ways to prove quads are parallelograms. Okay, so we are here. Okay, so in 5.1 we learned what parallelograms are, the characteristics. You remember there was a definition, and then 4 characteristics, there were theorems. And then we are going to learn here how to prove that quad is a para. Okay, so the objective 2 is prove that certain quadrilaterals are parallelograms. Okay, right, so here are the ways to prove quad is a para. Okay, so theorem 5.4 is if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if these are congruent and these are congruent, then it's parallelogram. And the proof is that we draw this line right here. And since these are parallelogram, 3 and 4 are congruent, and 1 and 2 are congruent. So by side, angle, side, you can make these two triangles congruent. Well, actually, I'm sorry. Plan of proof, let's see. QS, draw QS, and then TQS. These two triangles are congruent. Then, okay. All right, so it's a side, 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 actually. So this is side, side, and side. So then these two triangles are congruent. Then these are corresponding angles and these are corresponding angles. So by 3 and 4 being congruent, these have to be parallel, and being 2 and 1 congruent, these have to be parallel, and therefore this is a parallelogram. Because remember, the definition of parallelogram is that two sets of opposite sides are parallel, right? Okay. And then these theorems, for some reason, don't have the proofs. But it's not that hard to come up with. But we are not going to prove them. Okay, so if one pair of opposite sides of quadrilateral are both congruent and parallel, then the quadrilateral is a parallelogram. So in this case, if these are congruent and also parallel, okay, then these are also parallel as well. Okay, so that's this one. And 5, 6. Think about how to prove this one. Why don't you think about how to prove these ones? If both pairs of opposite angles are quadrilateral congruent, then the quadrilateral is a parallelogram. So this one is, if these are congruent and these are congruent, then it's a parallelogram. Okay, so just one is not enough. You have to have the both sets of opposite sides congruent. So that's this one. And then if a diagonal quadrilateral bisects each other, then the quadrilateral is a parallelogram. So this one is diagonal, and these are congruent, and these are congruent. Okay, so these are the 4. So here are the 5 ways to prove that quad is a para. Show that both pairs of opposite sides are parallel. Okay, so this is one way, obviously. That's a definition. So if they are both parallel, then it's a parallelogram. If both pairs of opposite sides are congruent, then it's a para. So the one pair of opposite sides are both congruent and parallel, then it's a para. This is the one that is used the most in the proofs to prove quad is a para. Okay, and show that both pairs of opposite angles are congruent, and show that the diagonal bisects each other. So these, you remember there are 5 characteristics. This was a definition and 4 others a theorem. So basically these are converses of all the 4 theorems that we did in 5.1, except this one. Okay, so this one wasn't in, it's not a converse of the 5.1. In the 5.1 there was another one that it said the consecutive angles are supplementary. Okay, so if it's a parallelogram, then consecutive angles are supplementary. If the consecutive angles are supplementary, right, this doesn't make a parallelogram. Converse of this is not proof, because think about it, like trapezoid, consecutive angles are supplementary, and this is not parallelogram, right? If it's a parallelogram, then two consecutive angles are always supplementary. But just having one consecutive angles supplementary, it's not going to make a parallelogram. Okay, all right. So here's some practice. So you're gonna do odds for homework, and we're gonna do evens. Okay. So study the marking on each figure and decide whether ABCD must be a parallelogram. If the answer is yes, state the definition of theorem that applies. All right, so this one is, it's 9 in the parallel, right? So this is a para, and this is one set of opposite sides, congruent and parallel. Okay, 4. This one is a diagonal bisecting each other, so this is a para, and diagonal bisects each other. Right. This one, okay. So this one is supplementary, so these are parallel, right? And these are supplementary, so these are parallel. Okay. So since these are, the two sets are consecutive supplementary, then that makes it parallel. Since two sets of parallel lines, this is a para, and two sets of opposite sides are parallel. Okay. All right. 8. These are congruent, means these are parallel, and these are congruent, but they are not necessarily be parallel. So this is not a parallel. We need to have congruent and parallel in the same side. These are parallel, and these being congruent is not going to make it parallelogram, because here, situation here, these are parallel, right? Here's a congruent side, and here's a congruent side, right? So this is congruent, and these are parallel, not a parallelogram. Okay, so this is a not para. All right, so you do the odds, and I think we are done. This is a short video.